Hi everyone, welcome back to my AP Calculus class. Today I'm going to teach BC only part again is about the infinite series. So I cannot solve every single part of the sequences and series, but I focused on 2020 AP exam BC part because this 2020 AP exam much different from normal years because of the coronavirus. They gave some part of chapter 10 is included in this exam. Some of them is an infinite series part. So I'll explain today P series and geometric series, harmonic series. Let's solve some problems about that. Let's start. At first, I just keep solving example problem is much easier to explain, okay? Example 7, a series of sigma k equals 1 to infinity 1 over k to the p powers. This one. This is exactly p series form. That form in sigma k equals 1 to infinity 1 over k to the p powers. We call this form p series. If p is 2, if p is 2, that means if p is 2, what happened? That means sigma k equals 1 to infinity 1 over k squared, right? Plug in 1 from 1 to 2, 3, 4, 5 to infinity. So if k is 1, so 1 over 1 squared. If k is 2, 1 over 2 squared. And then k is 3 squared, keep adding forever like this. Okay? This is divergent or convergent. Divergent means is kind of approaching to a number, but convergent means, the divergent means what? Is approaching to infinity or negative infinity, or approaching to is multi-values like 2 values, 3 values, all those kind of these diverges, right? So this series converges. The P series can convergent to a number only when P is greater than 1. So 2 is what? Bigger than 1. That's why this P series can convergent. Yeah, it's not divergent. Okay, so we call this series what? P series. When the P series can be convergent when only P is greater than 1, like these example problems. Okay, let's go to example 8. Example 8 is about harmonic series, okay? Harmonic series. Just a harmonic series is kind of P series, but if P equals 1 in P series, it will become harmonic series. So this is a harmonic series. Why? Because it's a kind of P series, right? Sigma k equals 1 to infinity 1 over k to the p powers. That's a P series, but in this case P equals what? P is equal to 1. I told you only when the P is greater than 1, the P series can be convergent, right? But in this case P equals 1, or P is less than 1, all those kind of P series just a divergent. So harmonic series is automatically always divergent. Okay? And then harmonic series is this form, right? Because the k is 1 is 1 over 1 plus, if k is 2, 1 over 2 plus, k is 3, 1 over 3. Okay? This form is exactly harmonic series. Harmonic sequences, it means what? Reciprocal of each term. They have arithmetic sequences. We call that sequences, original one is a harmonic series. Harmonic sequences. Some of all those terms, it is harmonic series, right? Think about what is the reciprocal of each term. 1 over 1 is reciprocal is 1. 1/2 reciprocal is 2. Reciprocal of 1/3 is 3. That means 1, 2, 3, 4, 5. That is perfect arithmetic sequences, right? That's why this sequence is harmonic sequences, and then some of all those terms harmonic series. Series means sum. The harmonic series is kind of P series with P equals 1, and then only P equals greater than 1, that P series can be convergent for harmonic series. That's why harmonic series is always divergent. Okay, you remember that? Number 9 is a geometric series. Geometric sequences is, what is geometric sequences? Just to find the next term, you keep multiplying common ratio. Keep multiplying the same number to reach the next term. We call that kind of sequences geometric sequences. Some of all those is geometric series, right? So what is nth term, general term of geometric sequences? An. You learn that in the geometry class or algebra class. So first term a times common ratio r in the n minus 1 powers. This is general term of geometric sequences, right? Geometric series is sum. Sum is sigma means sum, right? K from k equals 1 to infinity, a to the r, a times r to the k minus 1 powers. This part is exactly what general term of geometric sequences, right? That means what? If k is 1, a times r to 0 powers, that's just a. If k is 2, ar. K is 3, ar squared. And sum of all this forever. Okay? And then that geometric sequence, a times r to the n minus 1 powers. Okay? So what is the limit? Limit a times r to the n minus 1 power. Sometimes n equals n approach to infinity. The infinite geometric sequences only when r is greater than negative 1 and less than or equal to 1, it can be convergent. Think about it. 1 is included, right? But for the geometric series, this is geometric series, right? Sigma, this form. K equals 1 to infinity, infinite geometric series, a times r to the n minus 1. This part is a1, but sigma a is sum of all terms, that's why Sn. That is convergent. It can convergent only when r is greater than negative 1 and less than 1. 1 is not included. Be careful. For the an, okay, geometric sequence, infinite geometric sequence is convergent only when r is greater than negative 1 and less than equal to 1. But geometric series is convergent only when r is greater than negative 1 and less than 1. 1 is not included. And the most important formula is this. Okay, convergent to what number, what value? The formula is a over a is first term, and then 1 minus r. A over 1 minus r. This is the formula to find the number, the convergent to, when r is between negative 1 and 1. Okay, I summarize about geometric series, infinite geometric series. Let's solve some more problem about that. It is important part. So example 10. It is geometric series. 1 plus 1 half plus 1 fourth plus what is a first term is 1. What is r? R is kind of the number keep multiplying to get the next number, right? So 1 times 1 half is times 1 half, right? 1 half times 1 half to make 1 fourth. That means r is common ratio is 1 half. Keep adding forever. It is convergent? Yes, it is, because r is between negative 1 and 1. And then geometric series is convergent. To what value? The formula is what? A over 1 minus r, right? So in this case, 1 over 1 minus 1 half, which is 2. So this geometric series is convergent to 2. That makes sense, right? So memorize the formula, a over 1 minus r. Okay. I keep solving example. Yeah. Next examples. I'm gonna have 3 more examples, maybe until example 13 today. And in the next video, I'm gonna explain more series part, and then Taylor approximation in the next video. Example 11. Harmonic series. Harmonic series. What's the harmonic series means? Kind of P series when P equals 1. Right? This is a harmonic series. That means in sigma k equals 1 to infinity 1 over k to the first power, p power, right? It's a p series and when p equals 1. So p series is always divergent if p is less than or equal to 1. Only when p is greater than 1, p series is convergent. So harmonic series always divergent. Yep, to infinity. So always diverges to infinity. That's the answer. Okay, harmonic series always are divergent. Okay, two more problem. Example 12. Does sigma n over 2n plus 1 converges or diverges? Converge or diverge? What does it mean? You have to understand the relationship between an and Sn. If limit n approaches infinity of an, infinite sequence is not series. If that is not 0, it is convergent, but convergent to other numbers than 0, or divergent. And then that means what? Limit an is not 0, okay? Then limit s of n series, right? Yeah, infinite series is always divergent. That makes sense, right? So limit an is not 0, then limit Sn diverges always. What if the limit an as n approaches infinity, that is 0? Then limit Sn infinite series, yeah, is possible. Can diverge. Converge. It may be convergent. It's not 100% guarantee, but only when limit an is 0, okay, it is possible for limit Sn to be convergent. That means if limit an is not 0, always infinite series diverges. That makes sense, right? Okay, think about this part. I'm gonna make a limit over limit n approaches to infinity. An part is this part. N over 2n plus 1 is infinity over infinity form. The same degree, 1 and 1, right? That's why leading coefficients could be answers, that 1 and 2. So 1/2 is the answer, right? You learn all of these kind of stuff in the first chapter in AP Calculus last semester. I'm not going to explain again. Just, limit infinity over infinity form, and then the numerator denominator have same degrees. Leading coefficient of each is the answer, right? 1/2 is the answer. It is not 0. Limit of an is not 0. So limit of Sn, the series automatically what? Is converges. It diverges. It cannot converge. That makes sense, right? Because it is not 0. So that should be diverges. Okay, and the next problem. Number 13. Maybe last example problem today. Yeah, I will explain more than this next video. Does 0.3 plus 0.03 plus 0.003 converge or diverge? This is convergent because it is geometric series. What is a common ratio? So 0.1. 0.3 times 0.1 is 0.03. 0.03 times 0.1 is 0.003. So first term is 0.3, and then common ratio R is 0.1. The 0.1 is what? Between -1 and 1. That's why this infinite geometric series converges, right? So to what value? Is formula is A over 1 minus R. That was the formula we memorized. I gave you 0.3 over 1 minus 0.1, which is 1/3. So 1/3 is the answer. Okay, this geometric series converge to 1/3 because r is between -1 and 1, and then by a over 1 minus r, that formula, we can find the 1/3. Okay, I'm done today. So I just explained the really basic things about infinite series. I focused on the P series, harmonic series, and geometric series. All these three series are included in this 2020 year AP exam BC part. Okay, thank you so much for watching my video, and then please click subscribe and like and turn on notification. That helped me a lot. Okay, thank you again. Bye bye.